My name is Neil Jackson. This is Lab 2 entitled Lines of Charge for Physics 2212 Section P. Before I begin, here's a brief recap of Lab 1. Our main goal was to estimate the total charge found on one of the U-tapes, and this was achieved through some basic calculations using some fundamental physics principles. The main problem with this was that we generalized our system far too much. We assumed everything was point charges and everything was idealized, and that's simply not the case, and this lab aims to resolve some of those issues using the new material we learned in the class this week. And on the right you can see my results from Lab 1. So for Lab 2, we know that these two pieces of tape can be represented as a line of charge, which is roughly approximate to a charged rod that we talked about in class. So using that knowledge with superposition, integration, and net electric fields and everything, we can wind up finding a far better estimate for the total charge and forces acting on these tapes. And this lab allows us to gain a much better understanding of how we can and why we should and why we shouldn't break down objects into subsections to better analyze and learn from them. So before I jump into the results and the coding and whatnot, a quick little lesson behind what in the world is going on with the lab. So we're imagining that these two pieces of tape are approximately equivalent to a charged rod, which we talked about in class. And we can split that charged rod into multiple different point charges, right? And by summing together each electric field of the point charge, we're able to get an idea of what the electric field looks like. By breaking those little pieces of point charges down to infinitesimally small pieces and integrating over the length of the rod or tape in this case, we're able to get a beautiful view of the net electric field of one of these pieces of tape. And that's really what we're doing with the lab. So here's what my computational model wound up looking like. As you can see, I have the row of the charges on the top tape and the bottom tape, the forces acting on them, that being gravitational and electric forces, and the electric field exerted on the top tape by the bottom tape. And down below I have the magnitude of my electric force and gravitational force, which is only equal due to I had to manipulate the value of Q, or the charge on the bottom tape, in order to achieve that. Simply because this is becoming a more accurate model, you're going to need a different value of Q, because the one we measured in Model 1 wasn't sufficient based on our system. To take a look at my code, you can see I have some brief sections here that generally tell us everything what we need to know about what the code does, how I coded it, and how it makes the model presented here. So to move on to the what if and why questions. For the what if question, when we used the point charge model, which in Lab 1 I got 5.8 E-8 coulombs, whereas this current model I got 7.68 times 10 to the -9 coulombs. As you can see, this the answer for Lab 2 is a whole magnitude of 10 smaller than what I got for Lab 1, and that's simply because there's more point charges to analyze. And so when we integrate and we're able to get a much better idea of a full tape, we're able to get a better, more finite solution to the charge on our line tape. And then for the why, I basically said the same thing, except Lab 2's result was more accurate solely because the system was better. We picked a far better system, and the assumptions we made were less and less severe in Lab 2. And to sum everything up in the results, errors, and assumptions page, I have the results listed at the top of the slide, and then assumptions at the middle, where we assume there's no air resistance and that each U-tape was identically perfectly made. That's simply not possible, which attributes to the error, and the error can be found in the assumptions we made, as well as human error or calculation errors that tell us that our process wasn't completely perfect, and I hope to resolve it in the future. Thank you very much for watching. The link for my code is down in the video description.